Good morning. So today we're going to be doing our last lesson on 6.4, day 5, where we are reviewing angle of elevation and depression as well as finding side lengths. And in all these problems, we're just going to round to the nearest tenth, and a tenth means that we are rounded to 1 decimal place. Okay, so this first problem, our angle of reference is 42 degrees. Across from that would be the opposite side, but since nothing is labeled there, we're going to skip that. The 16 is across from the right angle, so that makes this the hypotenuse. And x is next to the angle, so that's going to be the adjacent side. So then, I always like to write SOH, CA, TOA on the top for reference. Now, which of those trig functions are we looking at if we have adjacent and hypotenuse? Well, that's right here, adjacent and hypotenuse. So we're looking at cosine. So cosine of the angle measure, 42 degrees, equals adjacent over hypotenuse. So adjacent is x, over hypotenuse is 16. And now I'm going to just put this over 1, set it and make it into a proportion, and solve. Cross multiply. 1 times x is just x, equals 16 times the cosine of 42 degrees. So let's go ahead and type that into our calculators. Make sure that your setting is on degrees and not radians. So I'll show you how to do that again, just in case. Clear out all that stuff. So if you want to change the setting, you're going to come over to the top next to the second button. It says mode, and you're just going to recognize that degree should be on. And once you do this once, you are all set. Hit enter on that degree. You don't need to do it again. Second mode again will be second quit. And now let's type in what we got, which was 16 cosine of 42 degrees. And we got 11.89. So if it's 11.89 and we want 1 decimal place, we look to the second decimal place. If it's 5 or greater, we round up. 9 is greater than 5, so it's going to be 11.9. And we don't know what the units are, so we can just leave it as so. All right. Next problem. We have Mr. Wiggins the cat, and he is stuck in a tree. In order to get him out of the tree safely, his owner takes a 10-foot long ladder and leans it against the tree where Mr. Wiggins is resting. The angle of elevation of the ladder is 68 degrees. How high up in the tree is Mr. Wiggins? So first, let's start by drawing a picture. So we have a cat in a tree. Okay. So first, let me draw Mr. Wiggins here, and don't make fun of me too bad. Let's do that way. All right. So there's Mr. Wiggins. I'll give him a little body too. Okay. All right. So there's Mr. Wiggins. And now let's get him up in this big tree. All right. Next we have a ladder. And the ladder is leaning against where he is resting in the tree. So a ladder is going to lean, right? So here's my ladder. All right. Now, we know that the ladder is 10 feet long. So let's go ahead and label that 10 feet. Now, we can kind of see it that we have a right triangle here because the tree is vertical and the ground is horizontal. So there's our right angle. Now, the next piece of information that they tell us is the angle of elevation of the ladder. So remember, angle of elevation, angle of depression is always from the horizontal. So here's my horizontal, right? and then it goes up, it's elevating. So angle of elevation from the horizontal is 68 degrees. And now, let's get that, there you go. Okay, so now that we have our angle of reference, the 10 is going to represent the hypotenuse since it's across from the right angle. Now let's see what else we want to label. What else are we asked to find? Well, we want to see how high up in the tree. How high up in the tree. So that's going to go on the vertical here. So that's going to be x. And that is where with respect to the angle of reference? Well, that's the opposite side. So which trig function are we using? So ka or toa? Opposite and hypotenuse will be sine. So sine of your angle of reference is 68 degrees equals opposite over hypotenuse. So x over 10. Put sine of 68 over 1, cross multiply and solve. So you get x equals 10 sine of 68 degrees. Let's go to our calculator and type that in. 10 sine 68. And we get 9.27. Rounding to one decimal place, that'll be 9.3. Now this time, we do have units designated in our problem. This was 10 feet, so this is also feet, so 9.3 feet. So that means Mr. Wiggins is 9.3 feet up in the air. All right. Next, we have a two-part question. So we can draw one picture if we'd like here. But it's up to you. So we have a military plane flying at an altitude of 6,000 feet when it drops a care package of supplies. The angle of depression of the package is 52 degrees. Okay, so first let's draw our airplane. So if you thought my cat was bad, you're in for a real treat with my airplane. There's our little pilot. Okay, and the wings of the plane. Okay. Alrighty, so it says that it is at an altitude of 6,000 feet. Well, altitude is height. So the height of this plane, height is going to be 6,000 feet. And now the angle of depression, because it's dropping a care package. So when it drops it, because it's moving, it's going to keep moving with momentum. So there's our triangle, and there's our little package. I'm going to make it look like a present with a little bow on it. Okay. So now, it told us that the angle of depression, now it's depression because it's going down, right? Well, it's going down 52 degrees. But remember, the angle of elevation, angle of depression is always from the horizontal. So you have two options. You can either make a horizontal line here and then put the angle of depression going down 52 degrees, or you can recognize that you have horizontal lines are always going to be parallel, transversal. So then what kind of angles do we have here? Well, those are alternate interior angles. So those two angles are congruent. So if that's 52 degrees, this is 52 degrees. So it's really up to you which way you want to draw it, but it's always going to be from the horizontal up, horizontal down, and they're going to be identical. All right, so now let's do question A. What is the air distance that the package is traveling? So what is the distance that is traveling in the air? Well, the package is being dropped from the airplane, and then it hits the ground down here. So all of this is where it's flying in the air, or falling rather, in the air. So the air distance is going to be x. Now, vertical horizontal line makes a right angle. So now, let's see which trig function we have. There's your angle of reference. So 6,000 is going to be labeled opposite. The x is going to be labeled hypotenuse. So are we looking at SO, CA, or TOA? If we have opposite and hypotenuse, sine. So we have sine 52 degrees equals opposite over hypotenuse, 6,000 divided by x. Now this time, there it goes, put it over 1. You should recognize that we have one extra step in our computation. We have 6,000 equals x times sine of 52. Oops, so just sneak that in there. X times sine of 52. Well, I want to solve for x, so I have to get rid of sine of 52. It's being multiplied, so let's divide. Sine of 52 degrees divided by sine of 52 degrees. So that means x is going to be 6,000 divided by sine of 52 degrees. Let's go ahead and type that into our calculators. All right, so that means that the care package traveled 7,614.1 feet through the air. So that is the air distance that it traveled. All right. Well, the next question is asking us, well, what is the horizontal ground distance that that package traveled? So basically, horizontal ground distance is, well, what would that look like for a displacement from the time that they dropped it to the end point? How far along the ground did it technically travel? So I'm just going to redraw my triangle with the given information there. So I still have 6,000 here. I have 52 here. So that was the given information. This time we want the ground distance. I'm going to use y this time just so I don't get those mixed up. I'm going to use y. So angle of reference. This is still the opposite side, but this time we're solving for the adjacent side. So are we looking at SO, CA, or TOA? Opposite and adjacent is going to be tangent, TOA. So we do tan 52 degrees equals 6,000 divided by y. Put tan of 52 over 1, cross multiply and solve. I'll do it over here. So 6,000 equals y times tan of 52 degrees. And then we want to get rid of everything else and just leave y by itself. It's currently being multiplied, so we divide both sides by tan of 52. And then you get y equals 6,000 divided by tan of 52, and that's going to be what we type into our calculators. So 6,000 and this time we get 4,687.7 feet. So let's compare those two answers just for fun real quick. So the ground distance is 4,687 feet, whereas the air distance is 7,614 feet. Well, does that make sense? Think about it. Let's go back to our pictures. We're looking at a right triangle. Remember, the largest side, which in this case is the air distance, should be opposite the largest angle. Well, isn't 90 degrees the biggest angle in this triangle? Right? They have to all add up to 180. So then this would be 38 degrees here. So think about it this way. So if this is 38 degrees, that means the longest side should be the hypotenuse, which it is. And 38 degrees is the smallest angle, so it should be across from the smallest side length, which is the ground distance. Now, is that smaller than the other two values? It sure is. So that's a way that we can check for understanding to make sure that we didn't make a mistake with respect to labeling the picture, because if that were to be the case, those values would not match up. All right, let me know if you have any questions, and otherwise, get to work. Take care. Bye.